Hello, so this is Kyle, and I'm going to be talking to you a little bit about a lottery system, and we're going to use Postgres to find frequencies and numbers and just start doing more data analysis. So first, we're going to do something called SQL, which is structured query language, on the lots2 schema. You see there? So right here, this statement, it selects a distinct A.N1. In A.N1, there's N1 through N6, and that corresponds to the ball number from the Mega Millions that was dropped. So the value of the ball number. Now they order them from lowest to highest. So N6 is naturally going to be higher than most N1s. If it's in the same row, it'll definitely be higher. But when you switch up multiple runs of 5-ball drops, sometimes N6 could be lower than another N5. But we're just going to analyze that and see what the results say. So what this statement here is doing is it's counting the number of repetitions for a N1. So if the ball number 2, for instance, came up multiple times, it'll tell us how many times. So when we run this, I have it ordered because I did order by count, and we labeled count as being count A.N1, where the least common ones will come up first. You see 30, 35, and the most common one for the very first ball, which is the lowest ball, lowest numerical value, is 2, which has come up 55 times. Now we can also do that for the second ball. I just change it to N2. And we run it. You see 46 is one of the least common, which makes sense because it's a very high number. So it's more likely that 46 would come in N3 or N4. And we see that 15 is the highest number. We can do that again with N3. And we see that 24 comes up 23 times. Try N4. And when we run this, 8 is very unlikely because a number that low normally comes in N1 or N2. We're already at N4, which is the fourth lowest or third highest ball. And the highest one we see is, or highest frequency is ball number 47, which came 27 also. And finally N6. Now N6 is special ball. It's called the Powerball, and in most cases, and you only, nowadays, it's only on a scale of 0 to 15, but in the past, it actually went up to higher numbers. So that's why you see numbers like 31 in there, 12, but the numbers that are lower, the reason they're more often is because for the last few rounds, they haven't been using the higher numbers, any number above 15, so the chance of seeing these, or the frequency of those coming increased because there were less options. And that's why 1 is number 21, because it's been there through all of them. Now we can make a histogram. We have an open database connection, and what this is set up is it's bringing it in from Postgres and to MATLAB. And when I click Run Section, this is the first ball, and this is like we saw before. 2 and those numbers were much more common than the other ones. We can do the same thing. 2. And you see more of a middle, and then that keeps going that way. And something that's you might notice right here, A equals cellmat or cell to mat. What that's doing is taking the direct data. 3 would correspond to N3. I can do 4, 5. And that's because it's more random. 6, the sixth one is not part of the lowest to highest. The sixth one is just the random that we talked about. And again, the 0 to 15 is the range now, so that's why those are higher. So now we can also write a SQL for the total number of balls. So if we're grouping every single column together and we want to find out the frequency. So right here, I did a select distinct statement and labeled A.N1 as ball number. Now these two top select distincts are what's going to come up as the column headers. So that's why I labeled one ball number and the other one count. And the rest, just add in the union statement, adds in the values underneath the A.N1, which we named ball number because it's more appropriate when you're adding in a bunch of other values that don't just come from N1. So as you see down in the table, let's go down here, you see the last statement, I ordered by ball number. So ball number 1 came up in two different n values, or two different columns, n1, and in this case it can't be n2 because n2 is second lowest, so the lowest that could be is 2. So this would be n6, which is the round that doesn't have anything to do with the priors. And then again, there's 3 rounds where 2 came up as a number. One of them is going to be n6, you're going to have n1 and n2. And then 3s, and this doesn't tell you actually what the ball placement is in order of n1, n2, and 3. Some of these you can assume, but what this does tell you is how many different places that ball has come up within the order. So if it only came up like 2 different places, you know clearly just because of normal fact that's not going to be an n4 or n5. But this just tells you how many different n's it came up in, and then it sums them for that each individual n. So if we look at 2, there was 12, 4, and 55. And for 1, 21, and 40. But now if we want to find the total number of occurrences, if you just combine all of them and just ball by ball, ignoring the row that they came in, or the order that they, from least to greatest, that they are, we're going to switch the schema to right here. Now, back in this one, I did a create or replace view. And so in my actual schema of lot, and then database lot 2, what I did was I created a view called overall ball drop. And that references this column. So now I want to go back and get this information. So leaving that up, I come over here and I do select distinct ball number, count ball number because I want to count the repetitions, and then which is with the number of positions that it fell in order, and then I want to sum the count, which I labeled as total occurrences. So that's going to be 40 plus 21 and 55 plus 4 plus 12, and just group it in the section for 2. So, and I labeled this one as another view, total occurrences, but I have that as a comment now, so when we run it, it'll come up as a actual chart. And now when you go down to the chart, you see that 1 came up 61 times, which is 40 plus 21. And 2 came up 71 times, which is 55 plus 4 plus 12, and so on. So this chart here goes in order of ball number, and you can look for each individual ball number and see how many times that ball came up. And I ordered by ball number, so that's why it went in that order. I didn't order it by total occurrences. Now, if we want to, since we're grouping all the data together, we want to see what a histogram looks like when you group all the data together. So what I did was I took the SQL that we just made, the new view of total occurrences, and I made a bar graph, which is basically going to represent a histogram because the total occurrences are in frequency already, and the only difference is each individual bar is only going to be 1. It's not going to be like a range of 10 where you just group them together. So when I run this section, you can see a bunch of little lines, but this still gives you a generalized picture of where the balls fall. We see that 2 and about 12 are the highest in frequency overall, and then it slowly dips down kind of like a sideways S, and then The numbers up here are a lot lower, just